in my virtual studio for this GraalVM Streaming Week episode, we have Christian Wirth, who is the team lead for the Graal.js team and the Truffle Ruby teams, and is an essential part of the GraalVM project. Hi, Christian. How are you?
Hi, pleasure to be here for my first live stream, I believe. Yeah, I'm fine, thanks. I'm reporting here from Linz, Austria, and it's nice weather. I'm in studio and recording a video, and I hope you enjoy it. And we have some interesting stuff here for you today.
Right. Thank you. Right, everyone who is watching currently live, the topic of today's meetup will be Graal.js, which is of course, GraalVM's JavaScript implementation, the JavaScript engine, JavaScript, which is one of the truffle languages that you can run on top of GraalVM. So what we can do here is we're gonna talk through. I have a rough idea and we have a sort of an agenda in mind. What changes in the JavaScript standard have been introduced in the ECMAScript 2021, and we're gonna look at some code examples, and Christian is gonna explain those and kind of highlight to us the importance, the implementation details, and in general, if you want to keep up with what's new in JavaScript, this is the session for you. And then we're going to talk a little bit about how GraalVM implements this and the particular details of the GraalVM's side. So if you stick around for enough time, then there will be some Java code on the screen. I'm pretty sure there will be some Java code on the screen as well. Right. So before we start, right, Christian, can you maybe tell a little bit, very briefly? I assume people would know what is Java and JavaScript and what is the difference, but can you maybe briefly talk about ECMAScript and what it is and what is the Technical Committee 39 of ECMA and the relation between all those things?
Yeah, sure. So I guess people have heard about JavaScript, and many of you will have used JavaScript either on a website to do some scripting of HTML or similar things, or used JavaScript on the server. Most prominently, people might be aware of the Node.js framework, which is the JavaScript framework. And yeah, JavaScript is often has this image of being a very weird language, have weird constructs and a strange definition, and it's often unclear, and it has some unexpected results when you use it wrongly. But actually, there is one hugely advantageous thing about JavaScript, which is that it has a very nice, very clear, very thorough specification. And that is this ECMAScript specification. ECMA, or ECMA, is the, I think, European Computer Manufacturers Association at the time. They renamed to ECMA. And they started to standardize this language, this JavaScript, and provide a language specification. ECMAScript, it started with 3.0, 3.1, people used a lot, then 5.0, then 6, which took a very long time to emerge, but had lots of new features. And at that point, the language really got traction. And nowadays, there is a new version of the spec coming out each year. And this Technical Committee 39 that Oleg mentioned is working at ECMA, and is made from people from all kind of different organizations, companies, open source contributors, individual contributors, all of whom have some interest in JavaScript or in ECMAScript. So it's the browser vendors. Google is there, Mozilla is there, Facebook is there, individual contributors who've worked on JavaScript for a long time, like Brandon Ike, who designed the language initially. They're still contributing to that committee and still make sure that the language evolves, and that it evolves in a nice way, in a way that existing code can continue to run, and that users are really satisfied, and that you get a good experience when you run this JavaScript or ECMAScript language. And since last year, Oracle specifically our organization, OracleLabs, is part of ECMA as well. So we contribute to this technical committee. So far, we've mostly tuned in, but right now we start to actively contribute, and we look at our own proposals, we look at our own extensions that we think should be in the language in the future. And we actively contribute there by making the spec better, by contributing tests, and last but not least, by having the implementation ready in our engine to prove that it's a good thing, that people can try it out, then they can run their examples on the engine. And that's one of the things we think Graal.js is especially good at, because of GraalVM, because of the truffle framework, the polyglot language implementation. It is really pretty easy to implement new features. Of course, you have to do the coding for whatever feature you want to have. But once you get the implementation right, once completeness is there, and once your tests pass, and when you use the polyglot API correctly and use the features we have, the branch profiles, the specializations, and all those things that we have, when you use them correctly, performance will be pretty good already. And that's one of the key features that we try to show also in JavaScript, that you can implement the language with very little effort to implement new features, to make them complete, correct, but also high performant.
Right, and that's a lot of praise, but I think it is well deserved, specifically for the implementation. I wanted to highlight this one particular bit about different engines and different implementations implementing different features at their own pace, and then influencing the standard through the implementation and through discussions. So this is a little bit different from how I understand for example, the Java community operates, where there is a spec device, and then there's an implementation of the engine, sort of, right? There is the JVM, the OpenJDK project, that sort of implements that. So there are no different moving parts, not moving parts, no different kind of engines.
Yeah, in Java, always
features by one, right?
In Java, always the spec comes first. So you specify it, and then the engines implement it. In Java, if you remember the wild days of the browser wars 10, 15 years back, every browser had his own idea how to implement stuff and what new features to add. But that's really horrible for the user, because you needed specific code for specific browsers. I don't think it was that much of a problem in JavaScript, but you had those problems, especially in HTML and CSS, also in JavaScript, of course. And that's one of the reasons why this technical committee 39 and why this ECMAScript spec got so much traction and was and still is so successful, because still engines develop their own features. They still provide their own contributions and develop features that they think are relevant for the future. But it's not so common anymore that a lot of people would use those new features before they have really been specified by the committee. Of course, there are tools like Babel and similar that help you use new features also in a compatible way, so that you can transpile your code to a version that is runnable on all engines. But if you want to get good performance and want to run it without transpilation and really run that out of the box on all engines, you need to wait for the ECMAScript committee to specify that. But again, if a lot of engines use that, if the community really says this is a good feature, we want to have that, and there is a lot of pressure on the committee, on the vendors, on the engines, then things are specified pretty quickly. And it also helps the committee, actually, because then you see examples, then you see the use cases, then you see what problems people try to solve. I think I have a very good example near the end of today on our agenda where we can talk about this a bit more, to talk when do you want to add a feature to a language, because you should add as little as possible features to a language, because you might be in danger of adding stuff that nobody uses, and in the end is only syntactic sugar and is high maintenance effort and not really helping people. But the more the community contributes and the more the community uses new features, tries out new stuff, the better this is. And this is really valuable to the committee, and it's actually used in the committee a lot. The most used term there, I guess, is web compatibility. So if something breaks the web, if something breaks existing code, this is really a no-go then for the community. So every engine has a lot of tests to make sure that new features don't break existing code or don't do it in a way that is like foreseeable and manageable.
Right. So the standard ECMAScript the ECMAScript language specification version 2021, right? This is the standard for year 2021, which is current. Is it fixed? Is it currently in flux? Are those features what is the life cycle there?
Yeah. So that's actually a tough legal question that you're asking here, because the committee itself has fixed the feature set already. So there is a draft spec out. It's public, so you can download it. Everybody can have a look at that. And the committee has finalized it and kind of approved it. That's the final set. We won't change anything on that anymore. But for some legal terms or for the policies of ECMA, it has now to be approved by the General Assembly of ECMA, which will take some time in June. So then all the members will vote whether the standard will be adopted. I believe that's a formality. I don't think the General Assembly has ever mingled with the specs in detail, because if a technical committee says that's a good thing and the current changes probably are not too controversial, then this will be approved in June. But it's only a real spec and a published specification by ECMA once the General Assembly says it is.
Okay, but for most intents and purposes, we can probably treat it as the more or less finalized set. So
right, and that's also good for engines, because it now gives all the engines a month or two more to polish the implementation and make sure it's really working at the time that the spec is published.
Right. So how does GraalVM implement it? Is it ECMAScript 2021 compatible? Are there features behind some option flags?
So we support all the features already, and we pass the tests for those features. If anybody of the viewers disagrees and finds something that doesn't work, I'm sure we'll have a bug or two somewhere. Please file a ticket on GitHub. But we are aware of no issues. We support all the cases. We support all the corner cases. We pass all the tests of those features. And we've been doing that actually since 21.0. So since GraalVM 21.0, all the features have been implemented, and we are in ECMAScript 2021 mode by default for JavaScript. Because as we have this changing spec every year, this is a flag that users of GraalVM of Graal.js can set. We always set it to a default value that we think is a reasonable one. And currently, as the spec is pretty much stable, we dared to set it to 21 by default already in the GraalVM 21 release.
Right, that was in April, so this is fairly new. All right, let's maybe talk about the particular changes to the language, and I will let you show what's new and exciting is in ECMAScript 2021. How are we gonna do this? You're sharing a screen. Let me just.
I'm sharing my screen. Yes.
Let me just switch let me just switch the topics really briefly. Right, so this theme, yeah, I can see your screen, I can see your stuff there, and I can also see your camera in the bottom right corner, which is pretty good. Okay, so we are watching Visual Studio Code, and we are seeing some JavaScript. Yeah, take it away from here, please.
Right. So one of the new features is String.replaceAll. So what I'm doing here is I define a string in JavaScript, And previously we already had on string several functions defined. There's a new one now, replace all, because what previously you could do was replace an element of that string. So now let me try to run that here in the debugger. I hope that is working. Yes, that looks fine. So we have a string value here. That's some text that I define here. And on the console output, you should now see, debug console it is, I replaced, in the previous line, I replaced Graal with GraalVM. But as you can see in the output, what actually happened is it just replaced the first occurrence. Because replace, that's how replace is defined, it replaces just the first occurrence. And there were workarounds for that, because obviously we want both Graal mentions in here to be replaced. So there were workarounds. You could use this replace function accepted not only a string, but also a regular expression here. And if you passed in a regular expression with the global flag, with G, then actually it replaced both occurrences. So both Graal are replaced with GraalVM down here. And that's good, that's fine, that solves the problem for most people. But of course, it's a bit cumbersome. Regular expressions are a bit tricky to use. You might have more complex cases. And in general, yeah, there was consensus that it's a good thing to have just a replace all function that takes a string here as a pattern and a string that is used as a replacer, and to then provide the functionality that you can replace all occurrences. And yeah, you see it now here marked with the 2, that the output of that was same as with the global regular expression above, that both occurrences of Graal are replaced with GraalVM. Pretty straightforward, no magic here. Of course, the replace all is a bit more complex. It not only accepts a string as pattern here, as before, a regular expression is still allowed. And as the replacer, you can not only pass in a constant string, but you can also pass in a function, a lambda here, which, let me go over that. What I did here is I replace every occurrence of the letter O in that string, I replace with a counting number. So the first occurrence is replaced with a 1, second occurrence is replaced with a 2, 3, 4. So this is the normal powerful replace function. The replace could do the same thing, but replace all now makes sure that really all occurrences are replaced. And as I said, you can also pass in a regular expression here as well.
So I have a question, right? It looks like a little, it's not a trivial change, right? It is changing the API of a very fundamental object, or a very fundamental prototype, right? The string prototype is like used in almost, I mean, in every JavaScript program, there will be strings, right? So how do you think, like, what are the considerations? Do people kind of enhance the prototype manually for their programs, and then the community, when you devise a solution like that, do you think about, oh, maybe some people added replace all methods to their like within their programs, just changing the string prototype? How is there a long life cycle of sort of announcing that we're gonna do this change, and then please check your manual kind of interventions with the string prototype for that, and how does it work?
That's very true, because one of the things about JavaScript, about ECMAScript, is that the library itself is not very comprehensive. It doesn't have a lot of features. By ECMAScript definition, you couldn't even print to the console. You could have no input, no output. There are a few string and array methods, and it is growing nowadays. There are literal strings, there are template strings, there are typed arrays, maps, sets. So the list is growing. But overall, if you compare it to other languages like Java or Python or Ruby, the list is pretty small in comparison. And so what a lot of people do, especially when they are using frameworks like Node.js or using libraries for the browser, they use libraries that help them get the job done. So I'm pretty sure many libraries out there exist that provide a similar functionality than the replace all. And those libraries would either provide their own prototypes, or would provide their own helper methods, their own global method that you could call to exercise the functionality, or, as you said, they would manipulate the string prototype. That's something that you can easily do in JavaScript. You can easily contribute things to the string prototype, and then basically change the behavior of all existing applications that would use that. Of course, no application would use replace all at the moment, so there is no danger in that. But what actually can happen in practice is that you have several libraries that provide the same functionality. So you have to take care, if you have two libraries that both would provide this replace all on the string prototype, that they don't step on each other's foot, that you have to make sure to carefully load your libraries in order, or however you do that then in practice, that the right functionality is used. And of course, that's also now the danger when you use a feature like that, that when we now provide replace all, that this could be in theory overridden by a library. I would guess that most libraries take care here and really check, does a function already exist? And if it already exists, it would probably not touch it and not add or change the behavior. So I would guess this is mostly compatible, but of course there could be libraries out there that by design, by their own choice, replace all function with their own implementation. And that might then lead to unexpected behavior, because this implementation that they provide might not be as compatible. It might not accept regular expressions. It might not accept the replacer function, or it might do something in a different order or whatever. So this is really something that might happen.
Right. So it's like, despite its seeming simplicity, I would say that this is a fairly fundamental change. But it's a nice quality of life improvement, so I would absolutely take it. Right. Shall we?
Yeah. So should we go to the next one?
Yeah.
Right. The next one is probably even is actually more amazing. It's private methods. So a while back, JavaScript introduced classes. I think it was introduced with ECMAScript 6 or ECMAScript 2015, which was a major change, and actually brought classes or a class abstraction to JavaScript. And but previously all functions were public, as you can see here. I mean, I put public in the name here, but in the end that's a function. And when you create now an object of that type, example, you can call that public function. And what was added in the latest release, and you immediately see that because it highlights that as the Visual Studio Code is amazingly good at that, at highlighting that this is a private field must be declared in an enclosing class. So what happened here, by prepending it with a hash, by adding hash to the name here, and also here on calling it, you specify this should be private. This should only be visible from within the class itself. So I made a new public function, public2 here. And in this public function, you can call a private function. That is allowed because you're in scope of the class here, but you cannot call it from the outside. If you try that, you get a syntax error. Or if we just try to execute it here, how did I call that? Private methods JS. Did I not save here? When I save, yeah, you get a syntax error, the same thing that Visual Studio Code was showing in the preview. So this helps you to write nicer APIs. This helps you to design classes in a way that you can really hide implementation details, hide data, capsule data as you would want to do it. Not something that would really amaze a Java programmer that has been in Java for 20 years or longer maybe. But it's something where JavaScript catches up and takes ideas from other languages and uses that in a nice way and in a compatible way, because previously you were not allowed to write hashes, so that cannot break existing code.
Right. This is a very cool feature, and I think it will definitely make code organization simpler. From a Java point of view, from a Java developer experience, my immediate question is, can I kind of use some sort of an unsafe and then make this private method accessible? Is there a functionality like that? Because that is what my Java developer mind jumps to immediately when I see that something is not accessible like this. Unsafe it.
So there is no unsafe by default, but JavaScript is very dynamic, and you could easily write a library or write some code that would help you to achieve that. I mean, basically, what you see here is that it's possible. You can get to that state somehow. You only need a function that is defined on that class to be able to access it. So either with some intelligent mangling of that class, like defining some global method on the class or on the class's parent class, you would be able to reach that, or with some support from the engine, of course. So for Graal.js, it would be easy to provide something like unsafe. We have not done that. It might be that other engines have it. Of course, in a debugger or so, you can always see that because the data is there. It's not secured. Yes. It's just not shown to the user, of course.
Right. Yes. I was just curious. I wouldn't assume that we are adding unsafe or unsafe named things to the implementation.
And it's not so necessary, because in Java there really is no way to get to that data. And in JavaScript, I think, or generally in dynamic languages, this helps the implementer to hide data a bit, but it's really not as secure as it would be in Java. So there are ways around that where you can get access to fields like that.
Right. That is a very good point. It is do not rely on that as a security measure, and just use it to help you organize the code. So when you export things, where other developers can rely and get access to instances for your classes, they don't touch the API that is kind of internal, which is very
right. And it will show you even a compiler warning here before we run it. That's also, people often say things like that cannot be analyzed before. Of course, there are many cases where in a dynamic language you cannot easily know what will happen. But in this case, the compiler, Visual Studio Code, can see that I'm doing something that is not allowed here, even before I run it.
Right.
Yeah, so let's go to a feature that is very close to that one, because this was a private method, and private accessors is a very similar thing, where JavaScript had accessors before. So for instance, you had a get name here, and let me remove that. That was just some debug code I added recently. When you create an example, you can, not by calling a function, but by calling something that looks like if it was a property, if it was just the name property, but in fact it's a function. So you could have a whole lot of functionality here that does way more than just return the name. This is how you can use getters and setters in JavaScript. And now, same thing as before, you can have a private getter that you cannot call anymore from outside. So we get the same error here, private field must be declared. But of course, we can still we can still get it or access it from another public method or another public getter, as it's here in the class. So again, from a user point of view, a small addition has a huge impact, of course, on how you implement classes. Lots of things needed to be changed to get that working in the engine. But for the user, probably a very helpful tool for better APIs, better encapsulation of data, making things more secure and more easily understandable, perhaps.
Nice. And if you are not familiar with JavaScript getters, this is the function definition. There is the get keyword that is before the function name, right? That's how you separate from a normal function which would not be executed when you just pass it through without the parentheses. Right, very nice, very nice. So quality of life improvements. Shall we go further? We don't have any questions, but if you have questions and you're watching us right now, please fire away. I think this is a good opportunity. Ooh,
yeah, so the next thing would be promises. There is a new static method on the promise constructor, the promise main object here on the global scope, which is any, and that accepts the result or resolves the promise when any of the input promises are resolved. And it just takes a random one of those that resolve. In practice, probably the first one that resolves will be executed as the resolved promise of that promise. So it kind of combines all those promises and just takes one. You can run 2 or 3 or many alternatives and just take one of the ones that are passing, that are resolved. Only if all of them fail, so all of them are rejected somehow, then the catch here, the promise is rejected as a whole, and you can execute it on the catch clause here. And they actually even introduced a new error type. So there is now an aggregate error class or type in JavaScript, because you need that to get all the individual errors from all the individually rejected promises, and you can query them with these errors. So let me also show that here in source code. I will just make all the 2 promises I have pass here or resolve. So JS Promise.any, yeah. And I mean, the promises are pretty easy and straightforward. What I do here, I just execute promise 1, promise 2, and print some output when I'm done. And we see here that first the console log. So first we are actually behind the promise already, but after that, when the promise handler is executed and kind of the event loop that we have on the back is executing all the promises, we see that promise 1 was the one to be executed. I can cheat here a bit. I can make promise 1 to be something that always fails. So I always reject it here. When I do that, you will see promise 2 will be the one that is accepted. And again, if I make both fail all the time, so if I take both promises are failing, then you will see that an aggregate error is occurring. So error here is an aggregate error, and the messages, so this errors array here has the 2 fail messages. So that's just another way how you can compose promises. There was a promise all before, so that allowed you to make sure that all the promises resolved without a failure. And now you have the any as well, in case maybe you want to access 2 different web servers and don't care if both deliver a result. You just want any result. You want one of them to pass, and you can use whatever is coming back.
Right. This is an interesting API, and you said that probably it resolves with the first result that it gets, but the specification doesn't make any promises regarding that.
I'm not sure on that. I don't have the specification now in the back of my head. I think it really says you can pass any of those, because there is I think there is no clear specification in what order you need to execute promises. So you have this event loop kind of in the back, where you have all the unhandled promises, and you just execute them as they come in. And I mean, especially in the case of, it might really boil down to what is happening in those promises, because in the case which we started from, let me show that again. So when you have 2 promises here, I mean, in the end, we're using asynchronicity here, but all that we do is really synchronous. So this is not blocking. This is not doing anything weird. It's just returning a result, basically. So here it might actually be that the order is pretty good, pretty well defined. But what you would really do in practice here is you would query a web server, you would query a database, you would query some external system, in which case there is no logical order anymore. Whatever result you get back first will be the first in your queue. So probably the correct answer to your question is the first that resolves will always be taken. But it really depends on your example, which is the first to resolve.
Yeah, absolutely. And then the follow-up question there is, does it have to wait for all the promises to like resolve or reject, or the first one comes in and it immediately triggers the then function on the any?
So again, I don't have the specification in the back of my head, but just from understanding what the intent of that specification is, the any just delivers back any resolved promise. So it doesn't matter whether the second one will fail or even terminate. As soon as there is one that is resolved, we can use that. So I don't think it has to wait for all the promises to resolve or be rejected. It doesn't matter. As soon as there is one that's resolved, we can use that one. Again, please double check. We should double check in the spec to really clarify that. But from the logic of what the intent here is, that's how it should be. It's different for the promise.all, because at the promise.all, you really have to wait for all the promises and make sure that all of them are resolved. Because if the last one takes a while and then is rejected, the outcome of the whole combined promise is changed.
I mean, we could test this with a simple like timeout and printing out in those resolve functions, but I don't think that is necessary. We can leave that as an exercise for the viewers.
Yes, right. That's homework for the viewers.
Right. So Dave in the chat is asking, is this the new async functionality? Yes, this is the new Promise.any API that was added in ECMAScript 2021.
So what Dave probably means is async await, which has been added, I think, in 2019 or 2020. So it's related. You can combine those features, of course, but the async and the asynchronous functions with the await keyword, that has been added before. So that's either 19 or 20. So that has been there longer. This is just another possibility how you can combine such functions and combine such promises
Can I do await and then just do a few statements?
Sure, you can await on the result of such a promise. Yes.
Yeah, but like, do I need to manually combine the promise and say like await Promise.any and then function calls, or can I just await and then a few expressions with some?
No, well, in that case, if you do await, you have to pass in a function that returns a promise.
Yeah. Okay. So there is
but
no
you could use you could use the combinator there. You could use Promise.any or Promise.all as and use their output.
I think we should champion an enhancement where you could await and then just with a special post syntax specify a few async functions, and then that would be the await for any of those.
Yes, so for that you have to convince the committee that this is much clearer, much easier to read than using Promise.any or Promise.all. And if you can convince the committee, yes, sure, then this will go through the proposal process.
Well, I will start working on the implementation as soon as possible.
Yes.
Right. Shall we go further? I see there are some weak references, which is very interesting, I think.
Okay, let's see if I don't need that anymore. So weak reference, I tried to come up with a small example here, and I really failed on the small example. So I used what Mozilla has on their documentation for weak references. Let me just first say what a weak reference is. I guess people that come from a Java world, they might have heard that before, because there it's not so uncommon to have weak references. But in JavaScript, it's something totally new. when you have a normal object, you create an object, you store that, then this would be a strong pointer. So this object variable would have a reference to that actual object with that data that might have many more references because it creates a huge array or it has some child objects that it references. So that might be a huge block of memory that is actually stored here. Now, the amazing thing of JavaScript, but also Java and other languages, is the automated memory management system. So the engine makes sure that a block of memory, an object in this case, is automatically discarded and removed from memory and not like counted towards the memory usage of your system anymore, as soon as there is no more reference to it. So once you leave the current scope, once you drop out of a function or something like that, then the system sees, oh, you're not using that object anymore, so I can remove it. That's called garbage collection. It's a component that's called garbage collector that does that checks, are there still references to the object? And if no, I can remove it. And that's pretty clever system that works very nicely. And yeah, everybody who's in this world and who's a programmer of JavaScript or Java will love that feature, because you don't have to remember objects, you don't have to free any memory blocks yourself. All this is magically done. But it comes with a trade-off, because in some cases you want to retain such a strong reference on an object while you actually don't care about that object anymore. And a good example for that is a cache. So you might have a cache on that object somewhere to speed up access to it, or maybe you have some data pre-calculated on this object, some I don't know, some hash value of that object. And if you do that, having this cache and having a strong reference to your object in that cache, and you need that to identify the object, or it's probably the easy thing to do to identify the object, this will make sure that the object lives forever, because it's in your cache, and the garbage collector will say, I cannot remove this object anymore. Even if there is no other reference from the rest of the system to that object any longer, it's still in your cache. So you've basically tricked the garbage collector and it will never be able to delete it. And that's where the weak references come into play. So when you use a weak reference, you kind of wrap that object as a weak reference object, and you would only store this wrapped object in your cache. And this is, in very simple terms, it's only a hint to the garbage collector, telling it, if this is the only reference to that object, feel free to delete it. We don't use that object anywhere other than in this weak reference, so we're probably not using it anymore. And as you can see here in the usage, you cannot simply access the object in here anymore. You need this dereference call, and the dereference call might return something that is null. So if it's null, then this is a hint that it has been garbage collected. It's gone. Your object is gone. So in that case, you can basically remove that entry from your cache or do whatever is appropriate in your case. But it makes sure that you can still reference objects in a cache, in a list, in whatever you need it to be, but still allow the garbage collector, if that is the only reference to that object, to remove the memory and avoid memory leaks, avoid memory blocks that are unused. So what the example that is here is we have this object, we make a weak reference on it, and then we tick on it. So every second we invoke a callback, and the callback every time accesses this weak reference, dereferences it, sees if the value is still there, prints out the counter and actually increases that counter, so this value here, and prints that out. And at one point in time, it might be gone. So the reference might be null. So then we print, yeah, the element is gone, and we clear the interval. And we actually also clear the weak reference here because we don't need it any longer. So what we also do here is after 5 seconds, we set the strong reference to the object to undefined. So we we delete that object here, which means the first seconds of our application, the object will be there. It will be in our main scope. It will be a global variable that you can access. But after that, it's gone. But remember, after that, it's still referenced by the weak reference. However, after 10 seconds, we'll basically force a garbage collector call here. This is a debug built in, so I need an extra flag. I need to start Node, in this case, our Node implementation with experimental options, and I need the debug built-in flag just to force that. In a normal application, you wouldn't do that. You would just trust the garbage collector to happen at the right places by itself. But for the sake of the demonstration, it makes some sense to really force the execution here. So let me run that, and you'll see the ticks now, 1, 2, 3, 4, 5. Then we'll delete the object. We set it to null now, but we can still access it, 6, 7, 8, 9, 10. And at 10, we called the garbage collector. And when we accessed the object the next time, we really see the garbage collector did its work, it deleted the object, and we print the element is gone because the weak reference was null at that point in time. So not something that you would need in normal programs a lot, but it has its usage. So when you know how to use that, especially when you need to implement the cache, it might be something very reasonable to think about and to use that.
Sorry. So in terms of, again, coming with my Java developer background, is it more, so in Java there are a number of references that are softer or weaker than the strong reference, right? So there is a soft reference, there is a weak reference, and there is a phantom reference. Which one, like, does the JavaScript weak reference kind of model any of those, or is it something kind of like a mix or something different?
I believe it's very close to a weak reference in Java, but it's not exactly the same thing. So I recall we had some troubles when we implemented this missing part, which I have not talked about, this finalization registry here, which is a callback mechanism to notify in case something is deleted. So there we had some troubles to get it really exactly correct according to the spec, because there are some very fine differences between how Java treats such a weak reference and what we needed to do. We got everything working and it was not too hard, but we were lucky that the spec was not too far off by what the Java system allows, because this is one of the danger kind of that we have, and again one of the interests why we want to be on the committee as well, to make sure we can actually implement stuff like that. Because if you design a very crazy language feature that needs to really dig deep into the garbage collector at that place, we would have a hard time to implement that in a compatible fashion on top of JavaScript, where you maybe don't have full support of the underlying memory management system to get it working correctly. In this case, it was easy. It was rather straightforward to implement that, but there is some danger that somebody comes up with a really weird feature that we could not support easily in this memory management area. But of course, I guess other engines have similar problems, and like manipulating your own memory management system is something that all the engines are very careful about, and really try not to do super weird things or even allow super weird things to the user. And if you read the documentation of these weak references and this finalization registry, every vendor and every documentation will tell you, don't use that. It's dangerous. You can break your code. You can break your application with that. So really only use that when you know what you're doing and you know you do need that code.
Right. Okay. So what is the finalization registry? I assume this is a similar thing to the reference queue in Java. This is how you can register a callback. right?
Exactly. You can register a callback, and this callback will be called in case that the object is garbage collected. So I just, same example as above, as before, but I just register on this finalization registry for our object a callback. We can pass in, which is called the held value. That's how the spec terms that. You can pass in anything. You shouldn't pass in a strong reference to yourself. So don't do something like that, because here you would shoot yourself in the foot, because this is a strong reference that would make sure that the object can never be garbage collected anymore, because you have one more strong reference to it. So you need something else, maybe call it object or held value, just anything that identifies your object. And when I execute the same example as before now, it will again take 5 seconds until we delete the object, and then 5 seconds until the garbage collector is called. Right, and again, we called the garbage collector, and before now our code triggered that we moved our weak reference and removed it from the cache maybe, we see that this registry was called, and we got the information that our identifier, our held value, was deleted. So that's another method that you can use to remove stuff maybe from caches, or update some lists, or make sure that you always have enough memory available, whatever you need to do. I think it will not be widely used, at least not by user code, but there are some uses for that, for libraries or for other systems that use a lot of memory and that manipulate a lot of data. So it definitely has its use cases.
I assume one of the use cases would be the integration with WebAssembly, right? Which comes with a very different memory management infrastructure, and well, your source language that you use to generate the WebAssembly could be like different, right? So if I use, I don't know, Rust with its like memory management facilities, right? And then I compile that to the WebAssembly, and I use that in my browser, and I interact with the JavaScript objects. Then if there are no weak references, then that is just memory leaks waiting to happen.
Right, exactly. And especially if you combine a lot of languages, like you said, in the GraalVM system, you can easily run 3 different languages, or 4 if you bring Java to the game. And you have some Python code that generates a WebAssembly library, and this library is then used from JavaScript. Welcome to some troubles when you want to use weak references there. Of course, it's not so bad if all of us use the same implementation, if all of us trust the Java weak references, because then Java will still do its job. But if you mix, and that's kind of the danger here, if you mix the weak references from JavaScript with weak references in other languages, in Ruby, in Python, then we really have to take care not to step on each other's foot, and really make sure that our underlying system, the Java as our host language, can really understand that both JavaScript and Python hold a weak reference, and yes, this is the same thing, and I as Java can garbage collect that already, even though both languages don't know from each other, and our JavaScript part would see the Python as the Python reference as a strong reference, and vice versa. But Java would understand in both cases it's actually a weak reference. So this is something where we will definitely need more good examples and more good documentation, and a few more thoughts on that to make it really perfect and avoid any troubles there, right? And WebAssembly, you mentioned that we're currently working on some WebAssembly support. This was also published in a recent version as an experimental preview from the JavaScript side. So it's not complete yet, it's not bug-free yet, but it can also run pretty amazing applications. And we're looking for feedback currently. So if you have any application, any JavaScript WebAssembly application, please try it out on GraalVM, let us know. If it's working for you, let us know what is working fine, what is not working fine. We try to polish our implementation currently, and we try to make sure that the next long-term release support version of Graal.js, of GraalVM, has some good WebAssembly support, so some JavaScript WebAssembly integration support.
Yeah, that is true. If you are running any workloads that combine those, or even individually, whether if you're running just some JavaScript workloads, give GraalVM a try. Right, it is a modern engine. Right. Do we have any more examples here for the?
So I think we have 2 more, if I'm not mistaken. Yes, but both are pretty small, so shorter than the weak references now. The one is logical assignment. Logical assignment is again not something super tricky, but it helps to solve a common pattern that you have. Basically, you have 2 variables. You have A and B. And say you want A to be a value. So if A really contains something that is not falsy, that is a true value that you can use in your application, then you want to keep A. But if it's false, like in this case, you want to assign a default value. You could call B a default value here. And then you would have a pattern that is similar to that. You could use a trinary operator as well, but in the end, you assign B to A. You could also implement that differently. Actually, you could say something like that. So if it is A already, then leave it. Otherwise, assign it. But this is a very weird pattern. In this case, you make sure that it's not assigned if it's true, because in this case, only the left-hand side would be evaluated, and it's only assigned in the right-hand side. But then it's not so well specified in what order, or it might not be so easy to understand in what order the values are evaluated. The above case is much more, I think, much clearer to every coder what happens. You evaluate the A, you read it once, and if it's falsy, then you assign B to it. So you have one read, one assign, everything is clear. And that's exactly what's happening here. So we have the new logical assign or operator, and it evaluates A, and if A is falsy, then A gets assigned B. That's all that's happening here. So it basically means assign B as a default value if A doesn't have a good value already. And there are 3 different versions you can use. You can either use the OR, so that checks A for falsy. You can use the I don't have an example here anymore. You can, or here's the example. You can use the logical assignment AND operator, so that only assigns Y to X if X is truthy, so basically the opposite of what we had before. Or you use the logical nullish operator, which does the same if X is nullish, so null or undefined in JavaScript. Again, not something super amazing. It's some small syntactic improvement that helps you write code a bit nicer. And once you're used to those operators, it's probably much easier to read and also easier to optimize actually for a compiler than a pattern like this is, because it's more straightforward to see what's going on here.
Right.
Yes. So again, that's just some small syntactic change that people can use and will be available in all engines pretty easily, because the implementation of that is pretty trivial.
I think it's just helping the compiler a little bit. That is like, to me, that would look as a part of the motivation, because indeed, the if block could contain anything. And if we have a special syntax for this particular operation, that kind of, as you have this use case just a little bit below on line 14 and down, right? So I would say I would see this as one of the main use cases for this operation, right? And if this is something that happens on the fast path, it just helping compiler even a little bit might be a good idea. And since it improves readability of the code as well, even though I might to me it looks a little bit strange, unusual, right? Especially the one with the question marks.
Yes, the one looks weird, but I think to a JavaScript program it's not so weird because the operator existed before. You had the double question mark operator before to check for nulliness, and people who use that operator already will have a pretty easy job of understanding what this assignment operator does, because it's very close.
Yeah, absolutely. And also there are other 3 character operators that are available, like for example,
the triple equals, which is very common in JavaScript.
The equivalents. Right, a cool addition. I like it.
So the last one is also syntactic sugar, but very important one, and that one is amazing why this was not added earlier. It's the numerical separators, and it allows you to add underscores to numbers with the sole purpose of making the number easier readable to a programmer. And I think that's very obvious when you look at that and separate the zeros here into groups of 3. It's on first sight you see that this is a million. But if I removed the underscores here, yeah, it's much harder for the eye to understand what's going on here. Where do I group those numbers? Oh yes, it's 6 zeros, so that's actually a million. If you add the underscores, no more doubt, you can see it on first sight. And this was added. You can not only use that for like a thousands separator, you can use it in any fashion you like. So as we see below, you can use it for bytes, for binary data to group it in blocks of 4. You can use it for hex to group it in blocks of 2, but you can really block it in any fashion. I don't think there is any limit what you can do. You can basically do an underscore everywhere here. If it makes it easier for you to read the number for whatever reason, then this is totally allowed. There are some limits, of course. You cannot have an underscore at the end of the number, or you cannot have it at the beginning of the number, because then it would be an identifier. It's not a number anymore, but a name. And you can, if you have a decimal point, you also cannot border the underscore with the decimal point. But other than that, you're free. If you want to have blocks of 3, that's fine. If you want to have blocks of 2, that's fine as well. Just use that for your own sake of readability of the constants that you have. So very small change, very trivial policy change, but I think it benefits a lot it helps programmers a lot to write easily readable code and have constants that people can easily read.
Yeah, absolutely. Even if this quality of life improvement allows you to avoid one single bug that you introduce otherwise, because the numbers kind of mix in your head between your eyes, then this is a good addition.
No more comments here like this is a million, or something like that. Yeah.
Yes.
Why use that if you can make your life easy and just have it like that and immediately see that's a million?
Yeah. This is good. All right.
Right. So that were nice all the features.
Summary. Mm-hmm. Very good. I like this a lot. What comes next? After the voting and after this becomes a part of the official spec, what is the beyond ECMAScript 2021?
Well, there are 2 things that will happen. There on the internet you can already see a draft of 2022, so that will again contain more features, more proposals. There is a proposal process in the technical committee, which is also very nicely specified. So anybody or any member can enter a proposal. It will be stage 0 first. It will be presented to the committee. If everybody agrees this is in principle something that we can discuss, then it will be moved to stage 1, and then you need some engine implemented, have some tests, have a specification text, discuss it in the committee again. It will advance to stages 2 and 3. And Finally, if you are at stage 3, you will present it again before the committee. If everybody agrees this is a well thought through proposal with a good specification text, which doesn't violate with any existing implementations, proposals, specifications, then they will advance that proposal to stage 4. And once it's at stage 4, it's basically part of the spec at that moment, but it will also be part of the next specification text, so 2022 in our case. And yeah, there are quite a few proposals in those stages. And as GraalVM, as Graal.js, we try to be on the frontier of development. We try to implement the relevant proposals. So basically, once something moves to stage 3, we're on high alert, because that means it might be in the spec anytime soon. In stage 3, we can easily implement it. And in stage 3, it also means the spec text is basically stable, except some bug fixes, maybe some corrections. It will also mean there is a high chance we have tests already. So the tests are specified and we can test our implementation. And so once something is in stage 3, we will assign it to somebody and implement it. But there are some amazing earlier proposals which are only in stage 1 or 2. There the job is a bit trickier, because those proposals might or might not advance to stage 4 eventually. In stage 3, it's pretty clear this will be stage 4 in a year or 2. There's some polishing going on, but it's clear that this is material that will land in the specification. But if it's only stage 1, it might be a very controversial proposal that might or might not land. But it's still something that could be interesting to us as well. We have some academic collaborators who could look into it, maybe to do some language research to help us figure out whether it's interesting, it's relevant, what is the impact of doing that. Can we implement it in a fashion that's high performant? That's something you can do quite easily on Graal.js, actually, because the implementation is often pretty straightforward. We have great support from Java. We don't need to care or implement so much ourselves, because the library is there, memory management system is there. We can just reuse it. And GraalVM and the truffle system, the polyglot API, in many cases make it pretty easy for us to implement such new features. So, for instance, one thing we recently looked at is operator overloading, which wherever you are coming from which language you're coming from, you might think of the best idea ever or the worst idea ever. But we've looked into it for the sake of understanding, could we do that? How easy is it for us to implement that, and what would be the impact? And we had one of our engineers, Jirka, worked on that, and we saw that with around 2,000 lines of code, we can get a full implementation of operator overloading in our engine. So that's an amazing thing. That's something that helps us to understand what this proposal is worth. Is it good to be implemented? What's the performance impact? We can measure that now. We can do our benchmarks, our tests. We can make a feature out of that and help our customers use that maybe in the future, whether it's adopted by ECMAScript or not. Of course, we would want it to be adopted. We don't want to be incompatible. There's always a danger there. But it's something that might help future customers as well. And we are now in contact with the original author of that proposal, and maybe help him to forward that proposal, or to understand what are the complications. Because if the more engines that implement the proposal, even in an early draft stage, helps moving it forward, because you have more trust that this is a good thing, that this is a working thing, that this doesn't break anything, and you can try it out. So that's one of the things we're working on. But again, that's in stage 1. So yeah, knowing that operator overloading in general is a very hot topic to be discussed, and we expect some people to oppose that in the committee. we're not sure yet whether this will ever be a thing, but we try to do our best. We try to help the proposal and try to move it forward as good as it goes.
Right. So I would assume that there is no specific help from the JVM, or like an implementation being on the JVM that helps with operator overloading, because Java doesn't have that. But I assume also, like, is my understanding correct that this is mostly useful when you work with all sorts of kind of numeric data, but that is structured in a way, like, so for example, accessing matrices or like linear algebra, stuff like that. So machine learning use cases and like, I don't know, like image manipulation and kind of things like that. Would that be kind of sort of?
Yes, totally right. You just hit the core of it with the numerical data, because where this is coming from for us is the MLE project. So there is a Oracle database variant, or it's now part of the core that you can use in the Oracle database, that's using GraalVM and using Graal.js, so the JavaScript parts, to access, I think it's used in Apex to write applications there, but it's also used, you can also write store procedures for your SQL workloads. And there, the operator overloading on the long term might be something very interesting to query data that's coming from the database, because this is structured in a different fashion. This is not a double as we would use it, a double precision number type as we would use it in JavaScript, but it has its own specification, and there is it's very well defined, of course, but it's different to all that you would usually have in JavaScript or even in Java to read and write and manipulate, add, multiply that data. And their operator overloading could be a very, very clean and very nice way to access, read, write that data. This is our motivation to look into that.
Right, very nice, very nice. Yeah, let's see how it goes. Do we have anything else that we are kind of, as a member of the committee, interested in? Any proposals?
So I have two more things that are on my list that we recently had a look at. So what we try to do as well, I mentioned academic collaborators. So here in Linz, I'm working close to the university, and what we try to do is also give bachelor theses to students here at university. And we recently had a few that implemented amazing work. One is already merged. It's called new set methods, an improvement to the set data type. One is a date time library, which is called Temporal, because the current implementation of dates in JavaScript is very basic, and it's not working nicely across time zones. And you can easily shoot yourself in the foot when you want to calculate some time zone difference that is really not well implemented currently. And to fix that, there is this Temporal project, which will bring a whole new set of date, time, duration, time zone, manipulating objects and primitives to the language. And that was also implemented, at least to some extent, by a bachelor student. And nice thing is, at the same time where he finished his implementation, the committee moved that proposal to stage 3. So now it's really on us to finish that, polish it, and make it available to everyone. So that will probably be in the next, or maybe in 20.3, we should land that proposal. And the last one is Decorators, which was also done by a bachelor student. And this is basically what annotations are in Java. So you can decorate classes and class fields and class methods, and specify in a declarative fashion some executors on those elements. But this proposal is a bit weird because it's in stage 2, but it will undergo a significant change still. So they are currently discussing that. The syntax will change a lot, semantics will change a lot, because they had some great ideas what this proposal can do, but in the end, the engines, the implementers didn't like it, because they saw no way how they could implement that without any performance penalty, even on cases where you don't use a decorator on your class, you would still have a performance penalty because the engine would have to do something about that and couldn't optimize away everything. So they will have to fix that before this moves to stage 3, which now means that our implementation cannot be used immediately, or we'll have to change that as well, along with the change in the spec that is still expected. But anyway, we have a good basis now, and whatever spec changes come, we will adopt them, and we'll have an easier path to completion from there. So that's also something where we try to reach out a lot to the community, or to interested people, to people doing bachelor or master's thesis, to help us implement that. Graal.js is fully open source, so the source code is out there. You can have a look at it, and you can help us implement features for it, which is, of course, then interesting for us as well. We get the implementation. You have an interesting bachelor thesis, an interesting task with good support. So that's, I think, a win-win situation.
Yeah, it is. It is, and you can potentially influence such a massive ecosystem as JavaScript. That would be a dream come true for, I think, when I was that would be a very massive success. So
Oleg, I will look for a small contribution, and we'll assign it to you, so you can help us get something implemented.
Yeah, absolutely. We should definitely work on the newcomer developer experience, and maybe look at some small issues and mark them as the good first issue. Graal.js is written in Java as the whole GraalVM ecosystem, right? Graal.js is a Java application. So maybe do you have an example of maybe any of those proposals, right? You mentioned in the beginning that it is sort of easier than some would expect to implement some of these, because GraalVM infrastructure, right? The truffle framework and the being on the JVM, the runtime provides a lot of functionality already. So if you have an example maybe of something that some changes there. Okay, I see you have an example.
I have something here, which is, I showed this replace all built-in as first example. This was actually done by an intern, so not a core member of the team, but someone who was fresh to the job, and who implemented that in late 2019. And you see the whole replace all built-in was implemented in just 220 lines, including comments, including everything. And yeah, let's have a quick look. He added the replace all with 2 arguments to our string prototype built-ins. We create a node here, so every major functionality we capsule in a node, in an AST node, abstract syntax tree, because we're an abstract syntax tree interpreter. And then this is the actual node, the string replace all node. It's abstract because we use some code generation to generate lots of the boilerplate code that we don't want to type for every node. We have a DSL that generates the code for us. This replace all node has a few child nodes. That's a primitive and annotation from the truffle framework. So we have a function call node and 2 conversion nodes that convert some input to a string, 2 different ones, because we might have different inputs that have different characteristics, and we want to optimize on them individually. We have a few profile nodes. This helps us optimize for cases and speculate on different patterns. So we have condition profiles, branch profiles, value profiles. Then there's a constructor for that node, nothing special. Here you see the specialization. This is this truffle DSL that generates a lot of the boilerplate code for us. And each specialization basically describes one of the input types, or one of the cases that our node can be in. And for instance, here we have a string cached case where where we can cache on some string value and assume it's constant. We have a plain string case, so that's the replace all case, where you have just two strings as inputs, but they are not cacheable, so that the first one is not cacheable. And then probably we have further down a specialization, that just uses generic input value. That's why we call it replace generic. So here the search value could be a regular expression, for instance, or the replace value could be a function call, as we've seen in our example. But if you go back to the search string case, so let me just take this one because it's the easiest one. For this specialization, we just get in the this pointer, so that the current this object, which we hope is a string. We have the search value, which is a string in this case, because we specialize on the string case here and the replace value. And we then basically execute this perform replace all. And this perform replace all is, what is it? A 20 line implementation of the main loop that actually does this replacing. So it searches for some string, replaces the string, and adds the result to a string builder, and in the end returns the result. So no magic there. That's mostly just typing out the specification one-to-one and implementing it as the specification says you should. And this is only the very first implementation. I'm pretty sure we improved on that stage over the 1.5 years that this was there. I think this can easily be improved by a few profiles, a few things I see missing here. But for a first implementation, this was not bad. This got the job done. And this was pretty amazingly fast initially already. Of course, we could optimize it further, and I'm sure we did so in the meantime. And you even see a comment here what you shouldn't do. But to get the basic implementation, all this string replace with different cases, with string as an input, with regex as an input, with string as a replacer, with function as a replacer, you get that done here in 200 lines of code. And this is already the interpreted code. This already makes sure you can compile it. You can compile it to machine code. It's fast in that case. It can be partially evaluated by Truffle, and it can be used inside a native image. So even if you create a native image from our GraalJS engine, this will also be ready for that. So new feature, 200 lines of code. I think that's not too bad. And just to give you another number, the operator overloading was done in around 2,000 lines of code. So that's really a complex feature with lots of impact everywhere in the engine. And still it only had a 2,000 lines of code change, which is not huge for a feature like that. And we only need to do it once in our interpreter case and get the rest, the compiler, for free. So I think GraalJS, GraalVM in general is a good tool to base your research on. If you want to try out features, if you want to try features and implement them, like this replace all here, or proposals or other built-ins, and you can't just do that with a polyfill. So you can't just do it with some JavaScript code or JavaScript library that you provide. Implementing them in Java here in GraalJS is a pretty straightforward, pretty easy way to get it done.
Oh, absolutely. This looks like the code that like anyone would be able to write. It's object-oriented. It's in high-level language. I assume this could be even simpler, right? So you showed that at the top of the node definition, there are a few child nodes which fix the structure of the abstract syntax tree. And there are also like a bunch of profiles, which is the performance optimization. So I would assume that the initial implementation, which wouldn't be maybe fast, but would probably be still correct, could be done without those. So and so those could go away. And then specialization, just to elaborate for for people who are not experienced in the GraalVM language implementation frameworks, in the Truffle DSL, specialization is a version of the implementation that is also sort of a performance optimization. So the engine that will run this code can pick the specialized method, one of those methods, based on the certain conditions, like the parameter types, argument types, or the guards that are defined in those in the annotation, right?
Exactly. So what I showed here, this specialization for the string case, where you can even cache a string, or the specialization for the string case, both of those you wouldn't need in an early easy implementation. You could just reuse the generic version, because the generic version, it might be a bit slower in some cases, but it still gets the job done. So even if your search value is a string, we would profile that here, or we would figure out the right thing here, and we would convert it to a string here and use it as a string. Then it might incur an extra check or two, but it gets the job done. So for a very first implementation, you could not do the above specializations for string, but just use this generic one, and then optimize from there as you see it necessary. If this is a built-in that is rarely used, or maybe that's only used for some initialization code, then you probably wouldn't improve it any further. But if it's something that your user code really can benefit from a lot to optimize, then you would optimize as far as possible, and try to get every single CPU cycle out of that for performance reasons. And you're very flexible on that. You can do that on a node per node or a case by case basis.
Right. That sounds lovely. So if you are a Java developer, or you would like to contribute to an interesting JavaScript implementation that is sort of, well, not sort of, it is compatible and it is modern, but it is also sort of on the edge, at the edge of the proposals for the language specification, implementing some of those at early stages as a proof of concept and as a particular features. Then take a look at the Graal.js, take a look at the whole GraalVM project, and I think it is very interesting that we have this. Right. I don't see any questions in the chats. Do we have any parting words, Christian? Would you like to say something?
Yeah, please use it. Try it out. Try the base engine, which is ECMAScript compatible. Also have a look at our Node integration. So we're Node.js compatible. You can run Node.js workloads on our engine as well. You can, in the Node.js integration, you can use all the interop features. We've not been talking about that a lot today, but you can interop from our JavaScript engine to Java. You can interop from our JavaScript engine to all the other languages we support, be it Ruby, Python, R, LLVM. So many options there. And you can run all that from within Node and interop, for instance, to a Java workload. And I think that's a use case that many people will love. There are no applications out there yet that can do that. So there is no market for that at the moment. But I think if people see that possibility, that will open many possibilities for use cases that you couldn't use before. Now, based on GraalVM, you can have a Node.js application that accesses a Python library, or that accesses some Java middleware application. So this is an amazing feature, and I would love to hear back from people using that, and maybe letting us know where we can still improve, and where we can improve tooling or features or performance even. So let us know on Slack or on GitHub, and we are happy to look into your cases and try to improve the engine further.
Absolutely. Thank you, Christian. This was very exciting and insightful sorry, it was a long session as well. We went through the new features in the ECMAScript 2021, and we looked at how it changes and adds some quality of life improvements to JavaScript. Very exciting new standard for the language that moves forward pretty fast. Christian showed us some code examples to get better understanding of what those proposals and what those changes kind of look like, and we even looked at a brief implementation of one of those API changes in the Graal.js engine. Right, so that was it. Thank you, Christian, very much. You mentioned Python, so there is the next stream in our live stream series will be a Python related stream on Thursday. So this Thursday at the, let me just quickly show that, at the Thomas's Twitch stream. Tim and Thomas would look at using Python from Java applications with GraalVM. And in a similar way, you would be able to use it from a Node.js application, as Christian just said. So that's it and done. Follow the channels, follow Thomas definitely to get the notification on Thursday. And if you have any questions about JavaScript, about our implementation, or if you would like to contribute, then please join the discussion either on the GitHub repositories, where you can raise issues or try to add functionality via the pull requests, or join the community Slack that GraalVM community manages, that you can find the links on the internet and join. There is the Graal.js channel. You're welcome to ask any questions about the existing implementation or about any features that are upcoming or implementation details. With all that said and done, thank you, Christian, once again. That was absolutely lovely. Thank you very much for your time. And
thanks for having me. See you.
Bye-bye.